Good morning to all of you. I welcome you all for today's lecture session on aero engineering thermodynamics. The topic of today's lecture is first law of thermodynamics for a system undergoing a process. Let us consider a system. So this arbitrary shape shows a system. It may contain a substance in the form of gas or liquid, and everything outside the system can be called as the surroundings. Now, let us consider the energy interactions between the system and its surroundings. We consider two energy interactions. One is heat Q and the other energy is work W. Here, heat is transferred from surrounding to system, that is, heat is added, and work is transferred from system to surrounding, that is, work is the energy removed from the system, or it goes from system to surroundings, right? So the net interaction between the system and its surrounding in terms of energy can be written as the difference between heat added and the work removed from the system. So I'll write like this: Q is added to the system, I take it as positive, and work is removed from the system, so I take it as negative, right? So the net of these two interactions will change the energy stored within the system, right? So here I will use letter capital E to indicate the energy of the system. The change in energy of the system is delta E, right? So for a system, the net energy interactions between the system and its surroundings is equal to the change in energy of the system, right? So this is the energy balance, or it is otherwise called as the first law of thermodynamics. For a general system, it may be an open system or closed system, I'll write the first law as Q minus W is equal to delta E. If the system is a stationary system or a closed system, I will replace delta E with delta U, because the energy of a system or energy stored within the system, E, can be written as the sum of kinetic energy, potential energy, and internal energy. So therefore, the change in energy of the system, delta E, can be written as change in kinetic energy of the system, change in potential energy, and change in internal energy. For a closed system, the change in kinetic energy is equal to 0 and the change in potential energy is negligible. Therefore, the change in energy of the system will be equal to the change in internal energy of the system, right? So that is why we write the first law for a closed system as Q minus W is equal to delta U. So here Q is the heat transferred to the system, W work done by the system, delta E change in energy of the system, and delta U change in internal energy of the system.